Hello and welcome back to Compiler Programming. Continuing with the theme of last couple of episodes, we want to do some more hardening of the internals before we really start to use the language properly. And one of the big things that is still on the list is proper support for x64 calling convention. So right now we have this code that deals with the first 4 arguments, and it also doesn't really support values that are larger than 8 bytes. So this is definitely something that we want to fix. Before we move on though, I noticed that we could probably use here a nicer version of the code, because we wrote this helper that is value register for descriptor, and I believe we could just use this here, and it will be much nicer to look at and easier to understand. So this is going to be register C, and then this is register D. Okay, this one is R8, R8, and the last one is R9. Okay, that looks good. Cannot convert from value star to value, so I guess we need to do this. Probably function argument list should also start using pointers instead of values, to be honest, but for now that's not really important, so maybe something I will do off screen. Okay. Oh, so something is not okay in what I did. That's kind of interesting. Let's quickly recheck what is happening. And all of that seems fine. Let's see the test that failed. So function returns 64, 42. What did it return? Okay, so this is the function in question. Let's open our debugger and see what's going on. Takes a second for it to come by. Where's our test? Our test. Okay, I think, yeah, it's this function that already fails. So let's see what we messed up. Actually, I want to see this thing. Okay, think. Okay. What is happening? So we are moving from array X to array X. That does not seem right at all. Did I mess something up in that function? So function arg, that's kind of interesting. So we have here argx and return x. So this argument should have been register A, or register C and not register A. So let's look at our definitions first and make sure that nothing is fishy there. So register C is different from register A. And just clarifying with these definitions. Yes, it's A, C, D, P. Yeah, that seems fine. So what is going on here? I'm not entirely certain. Oh, that would explain a few things. We are not actually using the register. So it's initialized to 0 by default, and um, and sorry, need to reopen this. And we are doing the wrong thing here. So where is our value for register? Yes. So this should be fine now. Let's run the tests. Okay, much better. In the last video, we were only using register A for in this form, so it's a good fix. Maybe I will commit it separately. Fix value register for descriptor. Okay. Continuing with what was going on, we have somewhere a test that checks for the third argument, and now we're gonna do even better. We're gonna say return fifth argument. So there's gonna be a bunch of unused stuff. 2, 3, return argument 5, and like so. Actually, it's already argument 4. Now we will need a function type that is going to be pretty large. But what can you do? It's going to be 2 more 64. Like so. And we pass more stuff, and we pass here. And now if we try to build, it will build just fine, because as far as C concerned, everything is great in our function. But if you try to run it, it's not going to go so well. Yeah. So we get this assertion that we added ourselves about more than 4 arguments are not supported. Okay, good. So this is our assertion. Now we need to figure out what's supposed to happen when you have more than 4 arguments. So this means that now we are going into default case. Whoop. I can type letter K apparently, JK. And we can actually put return here so it doesn't complain. Okay, now what is supposed to happen? I pre-opened a bunch of stuff, namely this page that we looked at before when we first started to work with passing function parameters, and it goes into a lot of details about this. The gist of it is written here, that first 4 arguments are passed in registers. Yeah, so this is the important thing. So it will be passed on the stack. Let's create a function that we can use like fifths, right? And it will take a bunch of arg0, 1, 2, 3, 4, and return arc4. Now we want int main that will actually call this return int fifths of 1, 2, 3, 4, 5. Okay. Let's see what is going on. I believe we can ignore these ones, because what this is doing is it's moving these first 4 registers into what's called the home area. We will deal with that a bit later. It's done for debugging purposes. So when debugger steps into the function, regardless of where you are in the function, it can know what the arguments were, because at the point where you are, there is no guarantee that the registers haven't been used for something else, right? So this is just a way to kind of stash information for the debugger. In release, I'm not sure that this is even happening, but you can definitely enable that. The interesting part for us is what happens with this move. So when we, in this function, we are reserving 56 bytes for all of the stack stuff. Out of those, okay, so this, it reserves, I guess, home area for the call, and then it puts it into here. The 24, 32. I'm a bit confused why it's 56. I thought it would be, 48. This is kind of actually, yeah, I thought it would be 48. Maybe because of alignment. The alignment should be 48 as well. Actually, no, because of the push of the return, it becomes misaligned. So yeah. So this argument is supposed to be on the 40 offset, and the stack grows in opposite direction, right? So just to visualize this stuff, let's kind of make a comment to help us out. We would have RSP here, and it points at the top of the stack. Then the doesn't look like there is anything at the very bottom, because that very bottom is just the padding, which we also have, I believe. It's this thing. So if I go into function begin or function end, I think maybe function and function, yes. So I believe that this 8 is the reason the 8 is here. So this is just alignment, and for the locals, it should go. This is kind of interesting. Okay. So it looks like our function builder needs to know what is the maximum amount of arguments that is pushed, that is used by a function that it calls. Because as far as I understand, like it's a responsibility of the caller to allocate this stack space for the function. If that is the case, that means I need to do some stuff. So we have stack for locals, and we have stack for the for the function calls. And I'm not entirely certain what would be the right way to handle it. Can I mix it in one stack reservation, or should I track them separately? I guess we can ask what Compiler Explorer is doing. So let's say we add 64T, 1 is 1, and we pass 1. So what is happening in this case? We are putting 1 at RSP, then okay, we need 2 of them. I guess 2. So 1 is at 48 and the other one is at 56. So they are at the so they are furthest away in the stack from where we are right now. Okay, that makes sense. But it also probably means that the way we are handling right now stack reservation is not actually going to work long term. Because right now we refer to stack variables as always kind of how to say, they are basically starting from the bottom of the stack, and if we need them to be further up, that's gonna change some stuff around, and we need to probably change a few things. So let's look at what reserve stack does and go from there. Reserve stack. Okay. So reserve stack, it gets the descriptor byte size, then it says that it will be at the current stack reserve. So I guess what we will have to do is patch the offsets between the stack locations and so for these operands, these stack offsets will be different, and we will only know that at the point where we finished processing the function. And this is kind of tricky with the way we are doing things right now. And I just need to make a decision. There are essentially 2 ways how to handle it. One way would be for us to keep it as is, and whenever we allocate something on the stack, we keep track, like whenever we use a value on the stack, so whenever it goes into here, right, we would, so whenever this happens, we would kind of remember, okay, what was the displacement, so this thing, for this value on the stack, and overwrite it with something else. That seems a bit tricky, but maybe we can try that. Another alternative would be to start changing things around in such a way that we don't actually right away encode things, but instead we get some kind of intermediary format that will deal with this stuff for us. So that if we do it that way, then for example, in this value, what we could do is we could have an explicit stack operand and encode this logic about stack offsets in there. This is kind of another way to deal with that. One more way would be to run the code twice. So basically have exactly the same things, but when we do reserve stack, it does something else. Now that probably is not very nice. Okay, enough mumbling about. Which option do I choose? I guess let's try the patching one, even though that might be a bit tricky. Okay, the first thing that we need to recognize is when we are in the referring to stack values. And this is happening over here. So in here, we will know that we are inside encoding a stack value. Let's create another variable and say bool encoding stack operand. Okay, and by default it's false. When we are here, we are saying yes, we want a stack operand. Okay, and then if we are over here, we basically need to say if we are encoding stack operand, then we want to remember what was the offset in the bytes that represent machine code for a particular displacement, such that we can later on replace it with the correct one. Okay, we need to store it somewhere, and we can actually just do, what's it, U32 offset of displacement, and we can use 0 as the sentinel value, because displacement can never be at offset 0. It's always somewhere off in the instruction. So say offset of displacement is buffer occupied. Okay, from U64 to U32. Okay, we can change it to 64. That's good. Now we probably need to change how encoding is specified. So it returns U64 and it will return offset of displacement. Sorry, it should go into here. Return 0. Okay, So now our encoding actually will tell us if we were using stack operand and what was the displacement of that that was encoded there. Okay, but this is only one piece of the puzzle, because now function builder needs to be aware of these displacements. Okay, for now I'm just gonna be very lazy and say that we're gonna have like a U64 star stack displacements. Or we need a bit more. We also need U34 stack. I probably should bring in some array library for C into here so I don't have to constantly do this kind of stuff, but it's fine for now. Okay. Now we say, so do something like define max displacement count is whatever. Let's do it this way. Not equals, just like this. If we need to, that actually doesn't happen over here. It happens whenever we encode a stack location, which is a bit awkward. So right now our encoder does not know about function builder, but it feels like it needs to, because we either need to change all of these things or we will have to do a bunch more work. So I guess we'll have to make the encoder aware of the function builder, which means, okay, which headers do you include? You include value. So I guess function builder goes from here and goes straight into value.h. Okay. Lots of problems. Let's try to fix them. And this is this. To bring it over here. That's fine. What else is the problem? I'm confused. Oh yeah, this is supposed to be like this. Okay, that's fine. Now I wanted to take the encoder, and so instead of the buffer, now it will get reference to function builder and builder. So let's just say that buffer star buffer is builder buffer. Okay, that's good. And now we have a bunch of things that we need to fix this. So I guess we'll do it like this. Oops. This is not what I wanted to do. And this will become just function. It should be ampersand over here. Okay. That's good. But now we have builder.buffer, and the replacement for that will be builder. Let's check once again. That's much better. This is something we can fix. Okay. Here it will be add function. We don't want this stuff for now. And we can get rid of this thing. Okay, so it builds. Let's see what happens. Something blows up pretty badly. Yeah, that's because we no longer have that assert in function arg, I believe. Yeah, so we still need to say not implemented. Okay, that's fine. We can disable that test for now because it will stop us from making forward progress. I'm not sure if I added this here. No, I didn't. Okay. I need to update the library. For now, we can just do this. Great. Okay, so what I was doing now we have builder here, and instead of returning this, we will do something else. So this no longer needs to do anything. And instead of returning the displacement, we would say that we assert that builder stack displacement count is less than max displacement count. Isn't it called? It is called max displacement count. Apparently I misspelled displacement. Okay, that's good. And now I will just put this stuff there. So do it this way, plus plus, and say builder stack displacements of builder stack displacement count is offset of displacement. Okay, that still works. Now the tricky part. We need to patch these ones to be something different. Okay, and that different will be done in function end. Okay, so we basically need to flip here the offsets. So if for example, if something was allocated last, it will have a larger offset, as you can see here. So like it instead of having a smaller offset. And the way we could do this, so this is stack reservation. For now, this doesn't change, although we will need to take into account the space for the home area of the function. But for now, what I want to do is this Philippe. Okay. And how would that look like? So we say for u64 I is 0, I is less than builder stack displacement count plus I. Okay, that's good. Now we need to take out the value that is there and subtract it from this from the stack size, I guess. We might also need to know what was the size of that value, because otherwise we have no idea. Actually no, we don't, because that logic will be part of our allocation. Let's just try to do this and then see what's going on. Okay, so we can say displacement. We'll need to cast it to S34, and we need to read it from the encoded instructions. We say builder offset builder. I don't remember how does our buffer look like. It's memory. So builder buffer memory and plus builder stack displacement. So let's save it into a variable because we might need to do that multiple times. Offset is this. Whoop. Yep. And now we say plus offset. And actually, let's do it this way. So convert it to displacement location. And once we have location, now we can read out the actual value and say displacement is like so. And maybe it would be a good idea to see if we are even getting something reasonable in here. So %d displacement and maybe /n. Okay. I don't like some stuff because this should be buffered dot memory. And what you don't like, that I misspell stuff. That's also fine. Let's check. Okay, we have a bunch of spam and none of it really looks like what we want. So something is not exactly right in what I'm trying to do. That's kind of interesting. Let's recheck what's happening here. So we are ending up in this branch, which is good. Is it possible that we are using this? Okay, I want to check like this. Okay, we are using it for some things, so this is something we need to look at later, but this is fine for now. I'm more interested in why this doesn't work. So this saves the buffer offset before we output this thing. And it seems to be the same number, which doesn't really make sense to me. Okay. The code still works. So this is all fine. But why we are here? Coding, if operand type. I guess we need to put it over here. Let me just check that. Okay, now it's even funkier. I'm really confused. Oh, yeah, that would explain some stuff. So what's happening is I forgot to actually initialize the memory, which is never a good idea. Or did I? No, actually, this is right in there, and but I probably want to do something like this, so this is not on the stack. Although really, who cares right now? If it works, it works. So I'm not sure. Let's fire up a debugger and try to see what's happening there. Let's go to our function end and see what's going on. Let's do here, or actually, let's do here. Okay. What is our offset? Offset is 0. That's not right. Oh, maybe that's the issue. Yeah, I guess here I forgot to add a condition to only do this if offset of displacement, then do this. Otherwise we are just doing kind of bullshit. And that explains those weird numbers, because they were basically just bytes for instruction encoding. Okay, this looks better. It still looks funky, but it does look better. At least these things are closer to what I would expect, although not really. Let's also put it over here and check only for S32 version of all of this, which we're not using. That's not nice, I guess. So we have our reserve stack thing, right? And that reserve stack does stack, which goes into value, and let's check what that does. Stack memory, indirect, RSP register, offset, offset. Okay. And what do we do with, oh, there is this funky code over here that we will for now disable, because I want to force it to always be S32, as we don't know what is the right size. It has to always be S32. At least if we don't switch around how we encode this stuff. Okay, let's continue. Run tests again. Okay, finally. So this is what I was expecting to see. 00880412. This is good. This is exactly what we want. I will actually not even add a fix me, because this is fine the way we're doing it. It's not very efficient, but it's fine. Okay. Let's continue. So now we have that location and we have that value. The displacement is okay. And what we want is to compare it with the stack size. Stack size and displacement. Let's run this. Good. And now we will need to essentially move them all by this size. I'm just thinking I will maybe need the size of the thing, which we don't have because of the stack. Okay, this is getting really funky, but I still want to push on, at least make this part work. I guess one way we can work around this is to just keep previous displacement. Okay. Displacement is 0. No, Siri, I'm not talking to you. Previous displacement is okay. Is 0. That's fine. And we say that on each loop, if I is not 0, so if it's not the first iteration of the loop, goes into here. So basically my idea is that we kind of know the size of the value based on the difference between the current and the previous one. Although if we only have one of them, then we don't know this. Let me think about that. Do we know the size of the operand in there? Not really, right? So, oh no, we do. So byte size is actually encoded here. So that means that we need to change some things around. Let's get back to value. We need to introduce another struct, and if struct, it's actually patch 32, sort of. Well, part of it. It's just this. Not really. Let's call it differently. Say it's stack patch, and here it will have U32 byte size and S32 location. That's gonna be maybe a bit easier to deal with. So we change this from being U64 to being stack patch. So obviously now create a bunch of errors, but this is fine. We can fix those errors. So the first thing is we can move this calculation of location to here, which is this stuff, right? So we can take it from here and put it over here. So it's buffer memory plus offset of displacement. Yeah. And now we can do const stack patch that will contain location and will contain byte size, which is operand byte size. Okay, that's good. Did I not call it byte size? I did. I'm confused. Operand. Yeah, operand has byte size. Operand that declares the identifier. Oh, okay. Yeah, we need to move this up a bit, or say U32 stack byte size is 0, and we say stack byte size is operand byte size. Okay, that's fine. Now we have stack byte size over here. Good. That's nice. Now we can fix it over here. So we don't want previous displacement anymore. We don't want this stuff. We don't want displacement location because now we will have that location. And we have stack patch, and let's verify that everything is still what we expect. So yeah, like this. And we also want to have the size, right? Because this is what we were trying to do in the first place. Byte size, patch byte size. And let's add another thing here, which is unsurprisingly byte size. Okay. Illegal indirection, yes. Okay. This is good. Let's see what we have here. Okay, so yeah, we have now the stack size. We have the current encoded displacement. Then we have the size of the operand, and now we can start turning it around in our coding. Stack size can be, let's say S32 current displacement is stack size, and we say that patch location is current displacement minus byte size. Okay. And now we say that current displacement, actually we can then do it like this. We first subtract the byte size, and only then we will do this. Okay. That builds, that's fine. Let's see if it works. It does not really work. Okay. So what is going on? Let's see. Let's look at our functions. Oh, this probably shouldn't this be positive or negative? It is positive because we subtracted the value of the stack, so now we are going up. Okay, before I dive into debugger, let me say that let's add a bit more information. So stack size original is this, byte or size is this, and new is whatever is star patch location. Okay, let's run the tests. Well, that seems fine, except that we we are now misaligned, so maybe that is actually the issue. Let's try it like this. Stack size minus alignment. No, actually maybe not. Anyway, let's just look into the assembly, which is the first thing that fails, so we can look at something. It is function increments S32 value past state. That seems rather strange, but let's try to look at this. Increments S32 value past state. Oh, okay, yeah, it does this stack stuff. So let's run this and jump into disassembly. Okay. So we are moving into the RSP. Oh, yeah, I'm doing really the wrong thing. I shouldn't be I shouldn't be changing this value at all. So this is wrong. It should be simple calculation where I say that this needs to be stack size minus displacement and minus byte size. It needs to be this way. Okay. Let's check that. Much better. Whew. There's still one failure. So let's comment this out and crash again and take a look at that failure. What is the failure? The failure is multiplies by 2. Okay, let's look at that code. This is funky. Why would that fail? Oh, because we probably do reservation of the stack inside of multiply. Okay, that's fine. Let's take a look. Ting, ting, ting. What is happening over here? We reserve 18 bytes of the stack. I believe this is the wrong function. Yes, this is not the one I'm interested in. I'm interested in this one. Okay, which is still roughly the same. Okay, so we reserve 18 bytes. At 14H, we put EX. That seems okay. Then we move our CX to REX. That's also fine. And then we do imul of this stuff. Okay, and what is the actual issue? We have this is a temporary value. So let me try to figure out what will be this RSP plus 0x14. And I'm just gonna cast this to int and say that it's like this. Operand of star must be a pointer. Okay, as you wish. It is a pointer. So this move is okay. And now we are IC. Okay, this actually discovered another bug that we have. And what's going on is now that we are sort of putting the stack in the right order, if the size of the thing on the stack does not actually match what is the size expected by the instruction, we read some memory that we are not supposed to be reading anyway, and it's a wrong value. So in here, as you can see, it uses arrayx, and so this is keyword, so it reads 8 bytes, but our value is only 4 bytes. So this is not exactly what we want. And that means that we either need to change the size of the other operand, or things will be very, very explodey. Let me find this function. Multiplies by 2. So what does it look like? Multiply x by 2. Yeah, this is not gonna work. We need to do this, at least right now. I think in C it might be an implicit cast in certain situations, like if it's a integer, like constant, but for us, I think right now it needs to be that way. Okay, good. So it does work right now. It doesn't look like we have enough time to actually tackle the topic that we want to be doing, because the episode ran already quite too long. So I think I will tackle it tomorrow. I know it's been a bit of a chaotic video, so if you stuck around till now, thank you very much for watching, and hopefully tomorrow we will tackle the stack allocation for arguments as we wanted to today. So thank you very much. Goodbye.